For this exercise, what we'll be doing is we'll be constructing, okay, so the question is you need to construct a stack that will be able to give us back the maximum value of the stack. So this means that if we have our stack and we are pushing the numbers, let's say 1, 2, and then 3, right? When we want to know the max value, the return value would be 3, right? But if we also, let's say, push 2, the return value should still be, so the max is 3 here, right? So one way of solving this the solution depends if we want to either optimize for time or do we want to optimize for space. So if we want to optimize for space, so no additional space, what we would do is every time we would want to get the max value, we would just traverse all the elements. So the runtime would be a little slower, but we wouldn't have to allocate any new additional space, right? And we would just return the max value from the stack. So this would be one solution. But another one, let's say that we want to optimize for time. So we want to have one runtime for getting the max values, would be just to have 2 stacks. So let's have another stack. So this would be stack and this would be max or maxes. And every time we push the values, we just push the max values to the stack. So we have 1, we push 2, and now 3, we push maximum value. But let's say that we now push 2 to the stack, which is smaller than the max, current max. So we just push the greatest values. So this guy, right? We compare the two. If the current number is bigger than the max, we just push the current value. If not, just push the max. And what happens is that when we want to get max, we just pick at the top, right? And this would give us one operation for the max, right? Cool. So for space, we're allocating additional array for this one, or stack, but it's still of n because it's 2n and we can drop the constants, so we're still at of n. So let's implement this in code. So if we have class max stack, so we need to have a constructor which is basically just nums or stack maxes, and then the API looks like this. So we need to have push num, we have pop, Jesus. Okay, we have push, pop, and what else? So max would give us back the max value. Cool. So we have 3 operations, push, pop, and this guy. So let's implement first the push method. Cool. So for stack, we can immediately just append num. But for maxes, we need to, let's say, have a value m, which is just number, and then if so if self, the point here is that we need to check if the maxes is empty, right? So maxes, if array has already have some values, right? If maxes, then we reassign m to whatever is max, right? From num to self.maxes the last value, which is current max. Okay, cool. And we can then just access.append. So that's it for push, and for pop we just pop both stack and maxes. Like this, and for max we just basically return the last value from the max stack. Right. Let's just implement the driver. Stack can be max stack. I'll just push a few numbers. 1, 2, 3. Then this guy. Okay, so what we expect? We expect to return 1, 2, and then 3, 3. 1, 2, 3, 3. Right. Cool. Just remove this and pop a few items here. So if we do stack.pop and then print the values, so now it should be a 3, and if you pop it should be 3 and then 2. Okay, so what do we expect? We expect 3, 3 and 2. 3, 3 and 2. Okay, this works. So that's it for this exercise. The variant could also be implement min stack, which the implementation would be similar to this one, only that we save the minimum value of the stack. Yeah, I hope you learned something, and see you guys next time. Bye.